Hello everyone, welcome to our second lesson video of programming with C++. I'm excited to continue this journey with you. In our previous video, we covered about the basic structure of C++. Now in this video, we are going to look into the most fundamental concepts in programming, such as the data types, such as Boolean, character type, the integer, floating point, float, size. And we also introduce declarations and learn the structure of declarations, declaring multiple names, scope, and initialization. So when you talk about data types refers to the various form of data that can be represented in a programming language. Data types are like different containers or bowls in a kitchen. You have containers for liquid, containers for solid, and containers for small items. And containers that is designed for larger items. Each containers are specifically designed for a specific purpose. In programming, data types work the same way. They tell the computer what kind of information you are storing and how to handle it. For example, handling whole numbers is differently than handle decimal points or letters. Now, common examples are the integers, which is the whole numbers, and floating point or float are for decimal point, and boolean for the logic, which is the true or false. And these data types, which is the integer data types, they can hold numbers. The integer hold both positive and negative whole numbers, which can range from negative maybe 2 billion to positive 2 billion. And the float or the floating point, they are data types that can hold decimal points with single precisions. Example are maybe the pi 3.14, negative 2.5, or 0.0001 or 0.002. And we have also another floating point called double. It's more precise than the single one. This can hold up to 15 decimal places, unlike the floating point with single precision, which holds up to 7. The difference between float and double is the accuracy. Double can store more decimal places, like I said earlier. And we have other data types such as the characters. Character data types holds letters, numbers, and symbols. Some like letter A, Z, the pounds symbol, and 5. They are all symbols that the character can also hold. And the Boolean data types can only hold 2 values, which is true or false. Which is true or false. Well, so when it's true, then it's 1, on, or yes, and when it's off, false, then it's off, no, or 0. It normally uses zeros and ones because it is computer. We have the string data type. And the string data type also holds combinations of characters, essentially text. Examples include hello world, and stuff. The string data type are normally in double quotations, but with the character data type, they are in single quotations. And these data types have their own data sizes. And data size refers to how much memory each data type uses. This is important because of memory limit. different operations have different speed requirements, and understanding size helps write efficient programming. Use the size of key to determine the size of a fundamental data types. So the integer data type uses 4 bytes for its operations, and the float also uses 4 bytes. The double uses 8 bytes. The character uses 1. The boolean uses 1, and the string uses 32 bytes. So without wasting much time, let's get into the practical aspect and of how this data type looks like. So I'll start with the integer data types. So to know or to use integer data type, you have to bring your int, which means integer, and an identifier, maybe any identifier, maybe age. That's our identifier. The assignment sign, which is the equal to, and you assign value to the age, maybe 25, then you terminate it. This is how the integer data type looks like. So, int age, assignment sign, 25, then terminate it. So we can output this by doing the cout. We talked about it in our previous video. Cout age end line, then we terminate it. So when we run this program, we get the value of the age, which is the 25. That's how the integer works. I chose 25 because their age are normally integers. So for the floating point, you have a type of floating point, which is the normal one is the float. The floating floating point. So we bring the data type, which is the float, and amount, or maybe price, or which is the identifier. So the float, the amount, the assignment sign. Because amount you can have decimals in amount, maybe 12.5, or that's why I'm using the float for the amount as the identifier for the float. Okay. 12.95, 3 or 5, then I terminate it. Then I cout. Cout amount. And then I finish. So when I run this program, I'll get the age and the amount, which is the string, the value for the string, which is amount, which is the 12.5. The 12.3, sorry. That's the value for the amount, which is the floating point. Now next, we talk about the double, which holds more decimal points. Let me write double floating point. So write your data type double, then your identifier. Maybe let me use type. Yeah, I bring my assignments and I assign the value. So the value for pi is 3.14159265359. Then I terminate it. Yeah, it is double because it has more than 7 decimal points or decimal places. Like I said earlier, that the double has up to 15 uh, decimal points. So when it's about 7, it is double, and above 7, between 8 and 15 is double, and when it's from 1 to 7 days for the float. See out. See out. High. End line. Then I terminate it. And let's run this program and see. So with this, I have my amount, which is the string, and my pi, which is my double, my amount, which is my float, and my pi, which is the double, and the h, which is the integer, all over. Yeah. Next, we talk about the Boolean data type. Boolean data type. So to deal with the Boolean data type, you have to write the word bool. We don't spell all the Boolean, bool. Then you bring your identifier, maybe has homework, has maybe has has homework. Oh, spelling mistake. It has homework. Then I bring my assignment sign. Then write true. Then terminate it. Another example is bool. It's raining. It's raining. Equal to false. Then I terminate it. So let's see out this program in C. See out. Has homework. Yeah, has home. End line. I terminate it, and the other one is to also see out. Is it raining? Yeah, it's raining. End line. So let's run this program and see the output of it. So like I said earlier, for the Boolean, if it is yes, the output is 1, and if it is false or no, the output is 0. So has homework, true or yes. So the output is 1. Is it raining? No. Or false, the output is 0. And next, we'll talk about the character data type. Talk about the character and the string data type. That's the next one. And we are going to talk about the character data type. So for the character data type, we need to bring our data type, which is the character, but we do it, we spell it as char. Don't write the whole character over the char. Then maybe grade, which is my identifier, grade, my siren sign. And because it is a character, it has to be in single quotation. Then I'll terminate it. Another example is maybe gender equal to let me use M for male, then terminate it. So let's see out this program and see out grade. End line and terminate. The next one is see out gender. Forgot to bring my quotations. Gender. End line and terminate it. So let's run this program and see. So there's no error in this code. So for the character data type, this is my output for the grade A and gender M for the male. And this is how we write it. Represent it in the single quotations. Single quotations. It's similar to the string, but there's different. The string deals with the double quotation. So next is my string data type. String data type. So for the string data type, you have to bring your string, which is your data type, and your identifier, maybe string, maybe name, the assignment operator, and you write any name, maybe Ama, then and terminate it. Let's see out the output and see out name. End line. Let's run this program and see. This is the string, this for the string, the name, Ama. So string data types are supposed to be in double quotations, and character data types are supposed to be in single quotation. This is the major difference. You have to put that at the back of your head to avoid mistakes. So we have another one called void. This one is more of a function. So let me do this, the void. The void is more of function. Like the user defined function I talked about the last time. So let's try the void. So void my function, which is my identifier, my function. My function then see out see out, just got home, end line, terminate it. So I'll come back to the main function and call this void function I just created. So in the main function, I'll just write my function, my function, my function, and bring my just terminate it. So let's run this and see what we get for the void. So for the void, the function we just created for the void and call it in the main function. This is it. Just got home. This for the void. So in next we talk about signed and unsigned modifiers. So signed and unsigned are types of modifiers that affect how numbers are interpreted. For the signed types can represent both positive and negative values. This is the default for most integers, and for the unsigned type, can only represent non-negative values, which is 0 and positive value. This allows them to store larger positive numbers since they do not need a reserved space for negative values. That's for the unsigned modifiers. It doesn't need much example, just the negative and positive part of the integer data types. We have other fundamental types too, which provides several other C++ provides other several fundamental types with different sizes. So we have short, which is typically 2 bytes for smaller integers because memory is important, and have long, typically 4 bytes, same as the integer on most systems. And have the long, typically 8 bytes for every larger integer. And these types give you more control over memory usage and the range of values you can store. Use them when you have specific size requirements. And you have other composite types, which are built from the fundamental types like the pointers, the arrays, and the reference type. We talk about the pointers, arrays, and reference type in our next video. And we have let's talk about the declaring multiple names. So for the declaring multiple names, instead of writing, let me comment this code before I continue. So for the multiple declaration or declaring multiple names, sometimes you need several variables of the same type. Instead of writing it separately, like separate declarations, you can declare multiple names or in a single declaration using commas to separate it. Your example is maybe int. Instead of let me do that. Instead of this, instead of writing int, x, then you terminate, then come down int y, then you terminate. Sorry. then you terminate, then you come down and write and W and terminate. You can do this instead. Do this instead. You can write just int x, then you separate it comma, y separate it comma, w, then terminate. Doing it this way makes the code look simpler and not as complicated as this. But doing it this way, you have a more lines of code, makes it complicated. So this is good. So we have different types of scopes. We have a global scope, a local scope, class scope, namespace scope, and statement scope. For this function I did here, for the void function I did, it's a global scope because it's above the main function. Global scope are variables outside the main function like this one, the void, like the void function I did over here. You can call it later in the main function. The main function like I did over here. We have a local scope. Local scope are these ones. This one, the integer data type. They are in the main function. They are in the main function. So let me do it this way to make it local scope. And there is global scope. That's the difference between local and global scope. Global scope above the main function, but you can call it later in the main function. And the local scope must be in the main function. It must be used in the main function. And we have variable declaration. Variable declaration. Like the same thing I did here. It's like the same thing I did here. Variable declaration. Then I declare this variable x. That is an integer. That's the example of the variable declaration. So must be declared before you. A variable must be declared before using it. This is like introducing yourself before having conversation. So the compiler needs to know what you are about to do or what it's about to do. And declaration informs the compiler what kind of entity the identifier refers to. It answers questions like, is this variable a function? Is this a variable or a function? What type of data does it hold? And how much memory should it allocate? So for this variable declaration, it's an integer variable, and it's going to hold letter x, letter for x. Letter for it, we are going to assign value to the x later. That's the variable declaration. So for initialization, initialization determines the initial value of an object. It's like setting the starting position of a odometer of a car. You are giving it a beginning value. That's the variable initialization. It's different from declaration. So if you want to initialize a variable, you need to, instead of introduce something like this, let me comment this one. So we can assign values to the variable we declared over here. It's the same as the initialization. So x equal to maybe 12, then you terminate it. y equal to 19 and w equal to 45 and determinate. This is the initialization. You're assigning values to the identifier of the declaration. Thank you very much for so in our next video we are going to talk about the arrays, the pointers. We talk about that one.